Hello and welcome to Libretro, one API to bring them all. This is for the FOSDEM 2021 conference. I'm so excited to be here. My name is Rob Loach, and today we'll be covering everything about RetroArch, Libretro, and the modularization that it brings to the table. Since FOSDEM has gone remote, if you have any questions, definitely write them down and come prepared to the live Q&A later on, or simply yell at me on Twitter. That's always fun. So, as I mentioned, my name is Rob Loach. I am part of the Libretro team members. I'm a web nerd and open source evangelist. Been in the web industry for about 15 years and have always loved game development and retro video games. I'm Rob Loach on Twitter, GitHub, and YouTube, so feel free to reach out to me there. But I am not the only one who's represented in this presentation. I want to make a big shout out to the Libretro theme. It spans across about 15 people and more. We depend on lots of contributions. For this talk, I do want to shout out TwinFX, Gauchi, Gadsby, and Kivitar for their help and contribution to these slides. Libretro is available at libretro.com. So check that out. And with that, let's talk about emulation. There's so many emulators out there. It's absolutely incredible to see how far it's come over the past few years. Being able to run older software on new hardware is essential in order for archival and digital preservation. There's Dolphin for GameCube and Wii, PC SX2 for PlayStation 2 emulation, PPSSPP for PlayStation Portable, Desmune for DS, Nestopia, FCEUX for Nintendo. It goes on and on and on. There's so many emulators out there, and it's so exciting to see. And even outside the emulation world, there's also a whole bunch of game frameworks out there and engines like Pico 8 or Doom with PR Boom. Scum VM for all of the amazing classic adventure games, and even more. But this causes a problem for users. As a user, it can be cumbersome to set up all of the different emulators. Each application has its own settings, input configuration, graphical user interface, so it can be difficult for new users to set up all of these different applications for each system. And in addition, it's also difficult for emulation developers. It's cumbersome to have to manage your own window logic, input, video, and audio playback. On top of that, how can you guarantee that your application will run well across different platforms? There's Windows, Mac OS, Linux on the desktop. What about mobile? Can you run your application on the web? How about smaller hardware like the Raspberry Pi? There are a lot of things to consider when you're developing your own emulator. So along comes Libretro. In this talk we'll be covering what it means to be a Libretro front end. We'll also be talking about what Libretro cores are, the Libretro APIs, covering some of the basics of that, and the ecosystem surrounding Libretro. So let's talk through some of the front ends involved. A front end is essentially a program that implements the Libretro API and interacts with Libretro cores. There are a bunch of front ends out there that can interact with Libretro cores, and I'll talk about some of those here. The first one up on the list is RetroArch. It's the primary reference front end for Libretro. It's available on Windows, Mac, Linux, Raspberry Pi, Android, iOS. There's a slew of different platforms that run RetroArch. So head over to retroarch.com to see if it's available for your platform. Some of the favorite features that I have RetroArch, our NetPlay, being able to run retro video games through NetPlay brings a lot of the memories of couch co-op and couch multiplayer. I love that. Being able to play retro video games over the internet is pretty awesome. Rewind is really cool. It lets you in real time reverse actions that you have taken in games. If you miss a ledge in like Mario or something, just rewind a couple seconds and try again. So cool. Input run ahead is also really, really awesome. When you're playing a game, it will take your input and apply those inputs to previous frames. So it gives you the illusion of reduced input lag. It just feels so much more responsive when you hit a jump button and it like instantly happens. Really awesome to see. And on the web, you can run RetroArch through the web using mscripten. Just head over to web.retroarch.com and you'll see like there's not as many features as the desktop application, but it's awesome to be able to run some of these cores on the web. Laka is awesome. Laka is a Linux distribution based off of LibreArch. LibreArch, I think that's what it's called. And it makes it so that when you boot up the device, it instantly goes into RetroArch. What makes it unique is that it runs on so many different devices, from the desktop to small CPU boards like the Raspberry Pi or the Odroid, to even handheld devices like the RetroFlag GPi case. Laka is an awesome solution for that, so I highly recommend you check it out. Ludo was written in Go. Its aim is to keep the most basic features to allow other people to learn how to design and build their own front end from scratch. I love how snappy and simplistic it is. It's very easy to load it up and get a sense of how to add your content to it and use it. Again, very basic, minimal front end. Great for ease of use. And speaking of ease of use, GNOME Games is an interesting one. It's focused on the GNOME environment. And having it just focused on that desktop environment means that it can take really great advantage of the environment itself. It's very easy to use. The user interface is very stripped down. And it's still relatively early on in the GNOME Games development cycle too. So have a look if you have any ideas on what should be implemented as part of it. Get involved. I also wanted to make a shout out for Kodi. Kodi's been doing some really interesting things with their retro player. Some examples of how cool this is that you can just in your own media center in Kodi, you can add your own games library and then browse them directly using your controller, and it's awesome. Still very early on as well, but I just wanted to make a shout out to Kodi and retro player. There's even more front ends available as well. Arcan is a desktop environment that brings Libretro directly into the Linux distribution. Actually, I'm not sure if it's a Linux distribution. Someone will have to correct me on that. So yell at me on Twitter or something if I'm getting that wrong. But I just love seeing Libretro used in places outside of just a single application. BizHawk is it's heavily used in the tool-assisted speedrun community. MUVR is a virtual reality application that you can, when you enter this virtual reality, you're sitting in front of a CRT TV, which I just love. I love that. And Lemuroid is a Android-based open source application project, which really adopts some of the graphical user interface features around Android, so it fits seamlessly in a mobile setting. So that's it on front ends. But what are Libretro cores? A Libretro core is a program that exposes the meat of their application through the Libretro API as a dynamically linked library. While these applications can have their own standalone implementation, this dynamically linked library allows front ends to use the Libretro API to interact with them in a modularized fashion. There are a number of cores out there, split across a few different categories. I'll just cover emulators, media players, and game engines or game frameworks for this talk. Some of my favorite emulators out there. I'd like to shout out Messin for NES. There's Higgin for SNES, MGBA for Game Boy Advanced, Parallel for N64, PXSX2 for PlayStation 2. These are just a few examples of emulators that have created Libretro cores. And while the standalone application exists, the Libretro core allows Libretro front ends to use them. DOSBox Pure is also one of the most recent cores added to this list, and it kind of blows my mind. It gives you the ability to load DOS games directly from a zip file, adds cheat support, having the ability to rewind directly in a DOS game is hilarious to see as well. So cool. You should definitely check it out. So while many people know Libretro and RetroArch for emulators, it goes beyond emulators. You can also use it to load media through some of the media Libretro cores out there. And since you can load up video files, you get advantage of using some of the features that RetroArch gives you, like shaders. In this example here, you can see we're applying a VHS filter to Big Buck Bunny. Really cool. I like that. I like VHSs. Anyways, outside of media and emulators, there's also a whole slew of different game engines and game frameworks that implement Libretro cores. One of the benchmarks for hardware is, does it run Doom? Well, yes, with Libretro. Libretro has a PR Boom core, so you can run Doom through any Libretro front end. There's also a ScumVM core. I grew up loving Monkey Island, so the ScumVM core is definitely one of my favorites. And if you're looking for a game to play, Cave Story, I definitely recommend Cave Story. It's a beautiful and fun Metroidvania made by Pixel, and it's free. The Libretro core for it is open source as well, so you can download it directly through the content downloader. And TIC80 is a small 2D game development framework. Many people use it to prototype some small games with it. I built the Libretro core for TIC80, and having to be able to run my own games on like a handheld device, it's just so gratifying, so cool. So I made this I'm in the way of here. I made this Dangerous Dave game in TIC80, and you can run that through the Libretro core for it. So yeah, really cool. So how does all of this work? How can you create your own Libretro core? Well, I could speak about this for hours. I'm only going to cover the basics of setting up a dynamically linked library with Libretro. I'm going to talk about some of the Libretro callbacks, video rendering, input checking, and audio concepts. And yeah, so let's get into some of those. So a Libretro core is essentially a dynamically linked compiled library that implements the libretro.h header file. It takes function declarations from libretro.h and defines those functions as callbacks so that front ends can call them. Libretro provides a standard makefile that you can use. A makefile is essentially just a definition file of how a program should be compiled. There's many different uses of it. The Libretro makefile is pretty standard. It lets you compile for all of these different platforms. So that's one that I use heavily. In the examples that we'll be talking about here, we will be talking about making a potatoes core. Yes, potatoes. So if we're setting up a potatoes core, the first thing that you'll need to do is create a potatoes.c file and define the retro get system info callback. When a front end boots up a Libretro core, it will call this function just to acquire some information about what the core is. Like the library name. In this case, we have potatoes as the library name, the core name. We're also defining the version, any valid extensions. So in this case, we'll be loading .potato files. And what happens when we start to run and load this core? All the Libretro front ends will call the retro init function. And in this function, you would put any initialization that you have for your core. There's also dinit, which will destruct any memory that you've allocated for the core. And there's also an environment callback that's called as well. Retro set environment will send you a environment function that you can call to grab information from the front end. In this case, we are setting that the core does not need a game to load. So in this case, we'll just run the core. It doesn't need a game to load. But if you are loading a game, you can use the retro load game callback. It takes one of two things. It either takes it either grabs a data buffer or a direct path to the core, to the content that you're loading. Yeah. And there's also retro unload game as well for when the core is done playing the game and you want to close it. So what does this look like if we're to run it? When you run a core, it repeatedly calls the retro _run callback. And in that callback, you're expected to update the game logic, update any input that you have, display the game, maybe play some audio. But what does it look like if we're to run it like this? If we compile our potatoes.c file into a potatoes.so or DLL file, what does it look like? If we're to run it with RetroArch-L potatoes.so or potatoes.dll, it looks like this. We have a blank black file. That's so exciting. We're making progress. But yeah, let's get some video happening here. Video is really important. So if we're wanting to display something in our core, we use the retro get system av info callback. This will set up how many frames per second that retro run callback will be called. In this case, we're setting it to 60, so 60 frames a second. We're also setting the width and height of the core as well. How the video will be shown. In this case, 320 by 240 is good. And I've linked. You can't see it right now, but there's a link to the Libretro samples repository that has a whole bunch of the samples that I'm talking about here. So head over to there, the Libretro samples repo. So now that we have our audio and video information set, what we can do is render our content. So in this case, we will be rendering a checkered board. Yeah, it goes line by line and sets the pixels into a frame buffer. In this case, the frame buffer is a unsigned integer taking up 32 bytes. Every byte represents a or 4 bytes rather, and every byte will represent a color pixel value. There's a once we set up the frame buffer, we send it off to the video callback function. So what does this look like when we run it? To run this core, we have two options. We either load it directly through the interface using the load core function, or we run it through the command line. In this case, I ran RetroArch -L and then potatoes.so, just like we saw before. So what does it look like? Hey, we have we have a checkered board. Yeah, it's really gratifying to see something actually happen on the screen in our core. So check it out. The Libretro samples will have all of this code available. And what about input? We talked about video. What about input? We use the retro set input poll function, and this will set our poll function to when we call it, the front end will update any input that's required. And then following that, there's the input state callback. And this input state callback will tell us information about the input. So in this case, we're checking if the up button is pressed on our gamepad. And if it is, we could do something like move the potato up, which is very exciting. All Libretro cores, they support joypads, the mouse, keyboards, touch pointers as well. Yeah, so really cool. Audio is supported as well. In this example, we are calling the audio callback with a solid tone. Let me see if I can get this running so that you can hear it. It's just a solid tone, but let's see if this works. So I just compiled our core. It's not on the screen, but I just compiled it and now I'll run it. Hopefully you'll hear a sound. Boop, boop. Solid sound. I like that. Boop. Very cool. So that's essentially creating our own sound, a solid tone. And every frame this is called, so you have to set up the audio to do it. And there's some audio cores out there that you can use as samples. You could load an MP3 file into this audio buffer and then play the MP3. It's up to you. So beyond audio, video, and input, what are some other concepts that we can accomplish with the Libretro API? Some of my favorites include serialization. With serialization, what you do is load all of the game state, everything about the current state of the running core. You can load that into a serialized object, and that allows front ends like RetroArch to handle state saves. It's also what's used for netplay as well, and input run ahead. So once you implement the serialized buffer, that allows your core to have save slots, which is really cool. There's hardware rendering as well. Cheats are in there with retro cheat set. Memory manipulation. You can also unlock your frame rate. In our potatoes example, we were running at 60 frames a second, but you can unlock the frame rate. There's also a virtual file system as part of libretro.h. Check it out. You can also send messages directly to the front end, so it appears as a message. Yeah. And Libretro API, it also there's many different implementations, different integrations with different languages and platforms. There's C++, there's Rust, there's Go. People have made a Pascal game. Pascal? Is that how you say it? Pascal. Yeah. Pong implemented in Pascal. And check out the Libretro samples repo again. Definitely go and try making your own integrations. If you like Node.js or Emscripten, definitely reach out to me. I've been very interested in the web side of this lately as well. So beyond the front ends, cores, and Libretro API, what does the ecosystem around Libretro look like? I'll be speaking about assets, the joypads, auto configs, the database system, and the build bot right here. So the assets. RetroArch comes with so many different assets associated with it. There's themes, there's overlays that people apply, different wallpapers, even audio for the menus. There's so many different assets that people need, and a lot of these are contributed from users. So definitely get involved with the asset systems. There's also auto configs. When you plug in a gamepad, RetroArch will automatically search all of device and product IDs in the auto configs and configure your joypad for you. There's so many different gamepads out there. So if you have a unique one that is not auto configured with RetroArch, definitely get involved with the RetroArch joypad auto config. We'll add it, and then you won't have to configure your device. It'll just do it for you. There's also the database system. In RetroArch, you can scan content, and it'll automatically add it into playlists for you. It's based on the CRC or the serial if it's disk media. Once those are defined as part of the database, RetroArch can scan the content and automatically add it in the playlist. So if there's some content that's missing, certainly visit the Libretro database repository and make an issue. We can add it in. And the build bot. The build bot's awesome. I love the build bot. It's a continuous integration server to build RetroArch in all of its cores. There's a new infrastructure for it as well. It's just so much faster. Thank you. Big thanks go to M4XW, who really led that effort. It automatically builds RetroArch for Windows, for Android, for Emscripten, Mac OS. Yeah, it's pretty amazing. And there will be a new blog post coming up within the next month detailing everything about the build bot, so stay tuned for that. So what's next for Libretro? We've covered front ends, what a Libretro core is, how to make your own core, and some of the ecosystem. Since its inception as SSNES and libsnes, Libretro has grown much beyond its upbringings. Libretro and RetroArch provide a way to connect different applications, emulators, and game engines together in a single application. So what's next for the project? We want to expand the build bot, finish the ARM Linux cores, Mac OS 64-bit binaries, and add more support for building more cores. We want to expand on the Steam release. The playtest is out, so keep watch for when you can get your own key to that. But we're looking to push that Steam release up. There's also the hardware support. Laka runs on so many different platforms and systems out there, but there's definitely more to come. And we also want to support your own cores. They're adding a Libretro core to your own application expands the user base, allowing for more portability on different platforms, and it also gives you access to a larger developer base as well. So certainly work on adding Libretro cores to your own emulators and applications out there. So that's it for me today. Thank you so much for joining me to talk about Libretro. I want to make a shout out to Blackbeard334, TwinFX, Gutchy, Gadsby, Kivitar for all of their help on setting up these slides. My name is Rob Loach. Definitely reach out to me on Twitter. I always love hearing interesting ways that people are using Libretro. So definitely give me a shout. I hope to publish more of these videos on YouTube as well. So let me know what you'd like to see. There will be a live Q&A session later on this week. So if you have any questions, reach out, queue them up, and we'll make it happen. Libretro and RetroArch are available at retroarch.com. They've been publishing some incredible videos on their YouTube channel as well, so check those out. And thank you to Fostum. This has been so exciting. I'm looking forward to seeing more talks this week, and it's been such an honor. So thank you so much. We'll see you soon.